All right, good morning, afternoon, superstars, wherever you're at. We're going to be doing lesson 10.3, 10.4, day 2. Just to give you a heads up, we've got some band friends in the media center going on. So you might hear some music in the background. But again, we're going to do that best that we can with our shared space. So we're going to go ahead and notice the difference between number 4 and number 5. Number 4 is more of a standard problem like we actually taught you with lesson 10.2, learning about our awesome rules of exponents. Had to turn the lights back on. But let's look at number 5, because number 5 is a little bit more representative of lesson 10.3 and 10.4 because you've got a nice negative exponent there. So there's two ways that you can actually do this problem here. The first way is noticing it's kind of like what we learned in lesson 10.2. So I've got my coefficients in the front, which are just pretty much basic. So 2 times 4, we're going to go in and write an 8. Then I'm going to look at my A and B separately. So for my A, I've got a 4, and I'm going to add to that a 3. Excuse me. For the B, we've got a 2, and we're going to add to that a negative 2. So we're going to definitely keep our 8. The A is the 7th power, and then our B, if you notice, it says 2 plus negative 2, which is really our 0 power. And if you remember, we don't have a 0 power, so we're going to go ahead and lightly cross that off, because that really becomes a 1, and 8 times 1 is just 8, A to the 7th power. So that's option number 1. Option number 2 is to try and change this second part here into a fraction, which is going to go ahead and look like this. 2a to the 4th power, b to the 2nd power, times, and then we got a fraction. We've got 4a to the 3rd power, and then the rule is to take your negative exponent from its current location, and then you move it to its new location, and in doing so, it now becomes a positive exponent. Then if you need to, you can put a little 1 there, and then if you notice, I could actually cross cancel. B squared and B squared really cross cancel to become a 1, but we don't have to write our 1 because again, it's just a nice integer 1. And then from there, you would have it behave like normal. 2 times 4 is 8. The a's are the same base, so we're going to go ahead and add our exponent. So we get 8a to the 7th power. So again, the exact same answer, two slightly different ways. Most students tend to prefer this method here, the first example. But again, if you want to practice changing your negative exponent into a positive exponent, that's how we would do it. So speaking about your negative exponents a little bit more, let's go ahead and look at number 7. So if you would like to, again, I'll show you two different options. Option number 1 is we're going to go ahead and use the rule. So that gives me each item getting the exponent. The u also gets it. So 4 times 2, because again, it's inside, outside. And then for the v, same strategy, but this time it says negative 3 times 2. And I want to remind you, when you're in your final answer form, we do not want a negative answer. So that means it gives me, sorry, a negative exponent answer. Gives me 36 u to the 8th power, v to the negative 6th power. So again, we wouldn't stop there because we have a negative exponent, and we do not want a negative exponent for our answer. So really, we're just going to use that trick that we talked about in the previous one. 36 can stay as is. The u can stay as is. It's the one whenever you have a negative exponent. You want to change its location and therefore make it a positive exponent. So this is considered like on the numerator. So we're going to move it to the denominator to become a positive exponent 6. All right, option number 2 would be changing it in its initial problem. So you're going to make a fraction. So you've got a 6 u to the 4th power as the numerator. The v would move to the denominator and now have a positive exponent. And then you would have an outside exponent of 2. So still, we're going to go ahead and distribute that exponent. So I'm going to go ahead and write it like this. So that gives me a 6 squared. My u, same thing. It's u to the 4 times second. Don't forget about the v, which is at the denominator, and that again is 3 times 2. Putting it together, we're going to get the exact same answer as what we did on the other method. So really, you would be able to choose which one do you like first. Do you want to take care of the negative exponent at the end, which is what I did here on method 1, or do you want to take care of it at the very beginning, which is what I did on method 2? Again, your choice. However, certain problems lend a specific strategy. So if you notice, this is one of the problems that a little bit more complicated, where we're going to go ahead and cover up half of the problem. So let me see if I can set that up. I don't know if it'll work. Let's see. Imagine that's kind of covered up. So don't worry about that right now. So on the left side, if you notice, there's nothing I can really do there except for change it into a positive exponent. V to the first power goes to the bottom now, or to the denominator. So if you want to, again, you could write it as a first power. If it was the answer, we would not write it with a visible 1, but since we're still in work, we're good as is. All right, nothing else we can do there. So let's go ahead and move your card, your ID, whatever you got available, and cover up the left side to let us work on the right side. Uh-oh, something freeze. All right, so let's move it over. Okay, you're just trying to symbolize that you're covering up something, so you are not getting overwhelmed with all of that information there. All right, so let's work on the right side now. On the right side, again, you've got two options. You can deal with your negative exponent first or towards the end. Now, if you notice, outside is a negative exponent. So I'm going to suggest that maybe you hold off on this negative exponent inside. Let's go ahead and give each item the negative exponent. So that would be 2 to the negative first power. U, we would do, again, inside, outside. So it's 4 times negative 1. And then for the V, excuse me, negative 4 times negative 1. So 2 to the negative first power is going to stay as is for a moment. U is now negative fourth power, but notice V is now a positive exponent. So it might have been helpful, like I did here, to hold off on changing everything until the end. So at this point, I'm going to go ahead and say, okay, I would like to fix my information that has a negative exponent. So it means the 2 has a negative exponent. So I'm going to move it from its current location to the denominator. Again, exponent of 1, but you don't have to write it. The U, I'm going to move it from its current location to the other. In doing so, it is now a positive exponent. V, remember, V is now, it was a positive exponent at this step, so that means it stays a positive exponent at the numerator. All right, now I can go ahead and think about that information. Let me just bring it on down. Now we need to go ahead and simplify it. Now there's two ways again that you can do this. You can try the writing out method, but we're probably not going to do that. Let's go ahead and put an equal sign, fraction. Now if you notice, nothing's going to happen to the coefficient of 2. So I'm going to go ahead and write that as is. Then if I look at the u's, the rule I think is best for us is to subtract the exponents at the location with the larger exponent. So if you notice the u at the denominator, that's where the larger exponent is. So let's go ahead and write 4 subtract 2. For our v, the larger exponent is at the numerator. 4 subtract the smaller exponent. So this is going to give us a simplified answer. 2 stays the same. The u is now squared at the denominator, and the v is now cubed at the numerator. So again, I know there's a lot of steps involved there, but we're trying to directly connect to what we've done previously. Negative exponents got to turn into positive exponents. When you've got same variables, meaning same base, and one's on the numerator, one's on the denominator, you got to go ahead and simplify it, or essentially reduce it. All right, let's look at number 15. I think number 15 is actually a lot easier for us. All right, few things on number 15. First of all, how many of you noticed y to the 0 power? Lightly cross that off. It becomes just a basic 1, an integer of 1, but we can just ignore it. Our coefficients are going to behave just like normal, meaning it's going to be a negative. And what can 10 and 4 both be divided by? Well, they're both even numbers, so we're going to divide both by 2. So that's going to give me a negative 5 over 2. Remember, coefficients behave like normal. Now let's look at the variables. If you notice, we've got x's, x's. 2 ways you can do this again. First method is just simply changing your negative exponent into a positive exponent. So that means x is positive at the denominator, but it's negative 3 up here at the numerator. So I'm going to change its location, and I'm going to move it down below. Same thing with the y. It is a negative exponent at the denominator, so I'm going to change its location to the numerator. Now it has a positive exponent. Stays negative 5 over 2, but your x, if you notice, you've got kind of like a 1 and a 3. So when we add them together, we get a nice 4. And a y to the first power, well, you can just say it's a y. That's method number 1. If you want to, you can do method number 2. Now remember, it's still going to be negative 5 over 2 because the coefficients behave like normal. But for your x's, you have the larger exponent at the denominator. So you would show 1 subtract. And you're going to subtract the smaller exponent, which is the negative 3. Notice how that is now going to become addition, which is how we get our 4. Your y, of course, that just needs to be sent to the numerator. So we now have negative 5 over 2. My x is 1 subtract negative 3, really becomes 1 plus 3. So I'm going to write it as a 4. Oh, forgot to put the x there, sorry. And then, of course, the y stays the same. Excuse me. All right, go ahead and turn over to the back. We got just a few more. I want to actually find a nice, easy one for us. Number 23. You need a break from a difficult, challenging problem. So look at number 23. This is a great question for an assessment or actually state testing. It says, which is equivalent to x 12th over x to the third? So now remember, this one here really is a subtraction problem. So the x is going to have 12 subtract 3. When it's written as a fraction, you actually are going to subtract the exponents. So x to the 9th. So it's asking you which of the other ones, when you subtract, because it's the same setup, is going to give you an equivalent answer, meaning the exact same answer. All right, going to go ahead and mute myself for a moment. You can just keep the video running and give you guys about 30 seconds to try and figure out, is it A, B, C, or D? Now, you might have more than one answer. Go ahead and think about it. All right, what'd you guys decide? Did you decide answer A? Well, remember, we're going to set it up. 10 subtract 5. Does that give you a 9? No, it only gives us a 5. So cross off answer A. Answer B, well, we have a 16 subtract 4. That's going to give me a 12. So no. Between these two, which one is it going to be using that same method? Yeah, not answer C, because 14 subtract 4 is a 10, and we wanted a 9. All right, so that's just a nice basic one. Same thing for number 24. What is the value of n for this equation? Now remember, this is the same base. So that means if it's the same base, you can actually add your exponents. For you, as a awesome 8th grade student, you might just be like, duh, I know what n is equal to, because you can do basic addition. 6 stays the same, base stays the same. 4 plus n is 12, so you might be able to know the answer right away. If you need to show your work, you would go off to the side and set up your equation. 4 plus n equals 12. Single one-step equation there. Solve for n. If you need to show your work again, looks like that. Go ahead and write down your answer. Don't tell your partner. Write down your answer. See how awesome you are. Now compare it to your partner. Did you get n is equal to 8? All right, let's do one more on, let's do number 20, and then we'll look at 27. So for number 20, all right, looks like we can clean up some stuff inside, and then we can take care of our negative exponent outside. I think that might be the wisest choice. So x to the 0 power, well, that just becomes a 1. We're going to hide the 1. All right, our coefficients behave as normal. Negative sign is going to stay the same. 10 and 25 can both be divided by 5. So it means I've got a 2 and a 5. If you notice, I just have single variables, meaning I don't have an extra x and an extra y. So let's just change our location. So x from the negative second power, well, we can just move it to the numerator for a positive exponent. And then for this one, we're going to move it to the denominator. That might have been wise. There were other options, which again is starting with the negative 3. But I think this one, I think it's working pretty good. All right. So let's see here. What I'm going to do is give the exponent to each one, but I'm going to go ahead and think about the coefficient as the fractional coefficient, not as two separate ones. I think that might be helpful. Let's see, x gets 2 times negative 3. The y gets 4 times negative 3. Oh, look at that, Mr. Moreno. Come on. There we go. Whew. Almost made a mistake there. You get a negative exponent for that fraction as well. All right, so let's come back to the fraction in just a moment. Let's go ahead and jump to here. The x is going to be the negative 6. And the y is going to be a negative 12. But remember, for our final answer, we can't have it like that. The x needs to move to the denominator, and the y needs to move to the numerator. So from there, you might actually be able to find your answer if it was a multiple choice problem, being able to eliminate some wrong answers. If not, of course, you're going to go ahead and focus here. Now, let's not worry about the negative 3 for the exponent right now. Just imagine if it was an exponent of 3, thinking about your sign. Would our answer be a negative answer or a positive answer? Remember, it's based off of the exponent. If you notice, it's an odd exponent. An odd exponent tells us that it's going to stay a negative answer. You might be able to eliminate some wrong answers from that as well. So in other words, I really just need to work with the 2 and the 5. Now, here's a little trick if you don't remember it. So again, we're not worried about the negative sign yet. 2 over 5, negative 3 exponent. So the trick is the 2 over 5, it really can just change like this, 5 over 2. Because if I give each item the negative exponent, then that means I'm going to have to change each item's location, which means the 2 from the numerator would have to move to the denominator. The 5 from the denominator would have to move to the numerator. So you can use that little trick if you remember it. Which means I guess I could have used that trick at the very beginning if I wanted to as well. So instead of distributing a negative 3, I could have just changed the location of everything. But then again, I would have been changing the location twice, and it's just a little bit complicated like that. So hopefully you have that memorized. Excuse me, 5 cubed is 125. And 2 cubed is 8. So again, a lot of advanced steps there. Just try your best. All right, last one is number 27. This is a repeat problem, which we call spiral review. You had a question just like this on, I think, even some finals and things like that. Basically, we need to plot our points. So from the origin, remember, negative 3, negative 2. So that's left 1, 2, 3, down 1, 2. That's our first point. And then 3, 4, that's right, 1, 2, 3, up 1, 2, 3, 4. So we are trying to find the distance between these 2 points. So I would ask you to connect it. And the way that we would find our distance again is by making a right triangle. So we would just count it. So our horizontal distance is 1, 2, 3, 4, 5, 6. Our vertical distance is 1, 2, 3, 4, 5, 6 again. And then if you notice, it's just our Pythagorean theorem problem because you got a right triangle. Our goal is to find the distance, which is hypotenuse. So again, we're going to go ahead and say a squared plus b squared equals c squared. Run slow. So we've got repeated here. So we're going to go ahead and say 6 squared plus 6 squared is equal to x squared. So we've got 36 plus 36 equals x squared. So we're going to go ahead and say 72 is equal to x squared. Sorry about that. That's a little messy right there. All right, so to find x, hey, now it's running better. We're going to go over to the side, and we're going to go ahead and break up the square root of 72, because remember, we're going to take the square root of both sides. We are looking for pairs. Now, we already knew that it was 36 plus 36, so it's 2 times 36. 36, we already knew was 6 times 6. Ooh, some of you might know what's going on. So looking for our pairs, we've got a pair of 3s and a pair of 2s. So we're going to say that we've got a square root or radical. The leftover goes inside, and a pair of 2s and a pair of 3s on the outside. So that means it's going to be 6 radical 2 for the distance between the 2 points. All right, hopefully this has been pretty helpful. You're going to go ahead and do the best that you can to finish as much in class. And if not, it is your assignment. Remember, Friday assignments are due Tuesday. All right, be awesome.